Can I crack CAT in 6 months? If so, what is the percentile that I need in order to get a call from the top B schools? What should be the study plan that I should follow to get that requisite percentile? This and much more when you catch me on the 21st of May 2023 on the BYJU'S Exam Prep app as we decode 6 months to CAT 2023. So what's stopping you? Go ahead, register now.
Good afternoon, everyone. Welcome to BYJU'S Exam Prep. My name is Navin, and today we'll be doing another session on 500 most expected CAT questions, part 6. So obviously we do not discuss the exact questions because we don't know, but we draw an analogy. Looking at the previous year's questions and the sets, we try to solve them and see what logic is involved so that we are prepared if we get a similar question in CAT this year. So we'll be looking at LRDI today. So this is the first set. So 4 cars need to travel from A to B. 2 routes are available, one via M and the other via N. The roads from A to M and from N to B are both short and narrow. In each case, one car takes 6 minutes to cover the distance, and each additional car increases the travel time per car by 3 minutes because of congestion. So let's draw the route. So we have A and then we have another point B. Now the cars they travel from A to B. There are 2 routes available. One is via A to B and A to B via M, and then there is another route which is A to B via N, right? The roads from A to M and N to B, they are both short and narrow. So let's draw a thicker road from M to B so that we will remember that this is wider. Because A to M is narrower, so that means M to B is going to be wider. Same is going to be true for A to N, right? Okay. ठीक है. Now, in each case, one car takes 6 minutes to cover the distance, and each additional car takes the travel time per car by 3 minutes because of congestion. For example, if only 2 cars drive from A to M, so suppose there are only 2 cars that drive from here. So each car will take, because this is one extra, right? So travel time per car increases by 3 minutes, right? So had there been only one car, then it will take 6 minutes. But since there are 2 cars, it will take 9 minutes for each of them. Okay, it's not plus 9, it's actually 6 plus 3, which will result in 9. Okay. On the road from A to N, one car takes 20 minutes. And each additional car increases the travel time per car by 2 minutes. So if there are 2 cars that goes from A to N, so it's going to be 20 minutes normally, but because of one extra car, it will take now 21 minutes. Okay. On the road from M to B, one car takes 20 minutes. So if there is only one car, it will take 20 minutes. But if there is an additional car, it increases the time by 0.9. So this is 20 plus 0.9, which is 20.9. And the same thing will happen from A to M and N to B. So if there are 2 cars, let's say, so it will be the same as it had, as it was in the route AM, right? The police department orders each car. So there are 4 cars, right? So the police department orders each car to take a particular route in such a manner that it is not possible for any car to reduce its travel time by not following the order, while the other cars are following the order. So the last statement is about you have to think of a scenario where you can minimize the travel time taken by all the 4 cars. Okay. In no other way, apart from the logic you are going to use or the condition you're going to put, should be more than some other answer. So in other words, you have to minimize it, right? So the first question is, how many cars would be asked to take the route A and B, that is Akala Nanur Bakala route by the police department? It was a theta question, right? So let's quickly draw. So this is A, this is B, this route is M, right? Then we have A to B, this route is N. The time taken in the path AM is 6, and with every other car it's plus 3. M to B, this is 20, with every other car it's 0.9. A to N, this is 20, with every other car it's plus 1, and N to B it is 6, and for every other car there will be an increase of +3, which is same as AM. Now, since there are 4 cars, right? So we can see that if there is only one car that goes from AB via M, go to AB via M, it will take 6 plus 2, 20, 26 minutes. And if there is only one car from AB via N, it will still take 20 plus 6, 26 minutes. So one car each, if they travel, they will take each 26 minutes. That's the shortest time they're going to take. Now, since we have 4 cars, and if we take 2 cars on the above route and 2 cars at the below route, so here each car is going to take 9 plus 20.9, which is 29.9 minutes. And if we take the 2 cars at the bottom path, it will take 21 plus 9, which is 30 minutes. So that means the 2 cars on the route AMB will reach 0.1 minutes, that's 6 seconds earlier than the 2 cars which are going to travel A to B via N. Right? Yeah, good afternoon, Sonali. Right? So, question is, how many cars are required to take that path? You know? So can we say 2 cars each so that it is equally distributed because the timings are almost the same? If we take 3 cars above, the time will, the AM route itself will become 12 minutes, right? And there will be more. So the cars will take much more time if they travel, 3 cars travel A and B route and only 1 car travels A and B. So the answer is going to be 2 cars, right? A and B में भी 2 car जाएंगे और A and B में भी 2 car जाएंगे, right? Okay. Next question. If all the cars follow the police order, what is the difference in travel time in minutes between a car which takes the route A and B and a car that takes route A and B? So abhi we right away we solved this, right? We saw that this route A and B, the 2 cars that were traveling, they took a total of 9 plus 20.9, which was 29.9. And the 2 cars that were taking the route A and B, they took 20 plus 1, so that is 21 plus 9, which is 30. So looking at these 2, we definitely know that the difference in travel time is just 0.1 minutes, right? So B should be the answer. It's a continuation of the previous solution, right? So B is going to be the answer. Okay. Let's look at question number 3. A new one-way road is built from M to N. So the route was AMB, right? And the other route is ANB. Now it says that a new one-way road has been built from M to N. Now each car has 3 possible routes to travel from A to B. One is AMB, another is AMNB, and the third is ANB. Right? Now, A to M, if you remember, this is 6. This is 6, and with additional car, it's plus 3. This is 20, with an additional car, it's 0.9. This is 20, with an additional car, plus 1. This is 6, an additional car, plus 3. On the road from M to N, one car takes 7 minutes, and each additional car increases the travel time by 1. Assume that any car taking the AMNB route travels the AM portion at the same time as other cars taking the AMB route. Okay. So, the cars are moving parallelly. It doesn't happen that one of the cars will reach AM and then the other car will start from A. Okay. They all leave simultaneously. That's what the question is. This statement is about. And the NB portion at the same time as other cars take A and B route. So by the time the cars reach N, the other cars will continue from here. Okay. So that's what this is about. How many cars would the police department order to take the AMNB route so that it is not possible for any car to reduce its travel time by not following the order? Since it's again a theta question or फिर से वही चल रहा है. So this is a symmetrical figure, right? We have an I-shaped figure or a petal-shaped figure, and then we have a partition. So if you look from the A's perspective or the B's perspective, you will find that this is symmetrical. Of course, MN route is one way. So going by that logic, let's say that 3 cars start from here. When they reach M, two of them now move towards Mn. While that was happening, there was only one car that started from A towards N. Once it reaches N, the two cars that were already there who reached N, this car, single car, will join them, and all these three cars will eventually reach B. And this is a single car that will reach B. Now, why did I do this? See, if I have 4 cars and if I want to divide it into partition, if I say 2 cars take the top route, 1 car takes the bottom route, so there is a mismatch in the top and bottom. Top and bottom, they are symmetrical completely. So there are going to be either 0, 0 cars, 1, 1 car, 2, 2 cars, right? But it says that Mn route will need someone. So let's look at the scenarios. The first one being, if we take A and B route and A and B route, they both are going to have equal number of cars, which say let's 0. And the cars that are going to take the route A, M, and B, they are 4 of them. As in, all the 4 cars will take the Mn wala path. Let's see how much time they are going to take. Now, since there is one car will take AM path in 6 minutes, it will travel that path in 6 minutes. But since we have 4 cars, so for every car there is an addition of 3 minutes. So we will have 6, and then for every car we will have 3. So there are 4 cars, so it will take a total of 15 minutes for the AM route. Next, if we talk about MN route, there had been 1 car, it would have taken 7 minutes, but then since there are 3 more, so for every car there will be an increase of 1 minute each. So this is going to take another 10 minutes. Next, if we look at the path NB, which is same as AM, so this is going to be 6 plus 3 plus 3 plus 3, which is going to give us another 15. If we add this, 40 minutes lagega total, right? The next scenario is if A and B is equal to A and B is equal to 1. Okay, so only 1 car will take the entire path of the upper one and the lower one, while the A, M, and B route, 2 of them are going to travel. Okay. In this scenario, what will happen? So 3 cars will start from the top, right? So they're going to take 6 plus 3 plus 3, which is going to be 12 minutes for the AM path. If I talk about MN path, there are only 2 cars that are going to travel, which is going to be 7 plus 1 plus 1, which is 9 minutes. If we talk about NB path, this is going to be now 3 cars that will continue, right? So that is going to take another 6 plus 3 plus 3, which is again 12. So can we say that the 2 cars that we are talking about, they are going to take 12 minutes, then 9, then another 12. If we add all of this, this is 24 plus 9, which will result in 33 minutes is what they will take. What about a single car that is moving up? Okay, jo akele upar ja raha hai, what about that car? So if you talk about that car, it is going to take 12 minutes, right? AM path pe it will take 12 minutes. And then MB path pe it is going to take 20 minutes. So this is going to be a total of 32 minutes for that car. What about the car that takes the bottom route, A and B? So there is a single car that is going to take that route, isn't it? So this car is going to take 12 minutes to cover NB route. Why 12 minutes? Because it's not traveling alone. There will be 2 cars who will be joining them. And then it will take the initial 20 minutes to cover AN path, which is same as 32. So can we say they will almost reach simultaneously? 2 of the cars will take 32 minutes to reach, while the 2 cars, they are going to take 33 minutes. So overall they reach there in 33 minutes, right? So if 2 cars take the route AM and B, they take almost the same time, and we won't be able to minimize so far. What if there is no car that takes that route, right? Is this possible? Let's see. ठीक है. It doesn't say anywhere, right? कि it is necessary for us to send all the cars, not all the cars, at least one car via MN route, right? It doesn't say that. So if we take the third scenario, that AMB route and ANB route, they are taken by 2 cars each, and AMNB route is taken by none of them. In this case, isn't it going to be the same as the previous scenario, where the 2 cars will take 29.9 minutes, okay, who takes AMB route, and the 2 cars who take ANB route, they are going to take 30 minutes, right? 2 car ऊपर जा रहा है, 2 car नीचे से जा रहा है. As in AMNB route, nobody is going. So can we say the minimum that we get over here is going to be 30 minutes? Because the question is, it is not possible to reduce any car for its reduced. As in, you can't further reduce it. So can I say 30 and 29 से कम, 29.9 से कम तो कर ही नहीं सकते अपन, है ना? So how many cars the police department will order? So can we say it's going to be 0? एक भी कार को नहीं ऑर्डर करना चाहिए उधर से जाने के लिए, because it will actually increase the travel time, right? ठीक है, let's see what is the answer, क्योंकि 32 से तो कम ही है for sure. Okay, so the answer is 0. It's right here. Okay, next one. I believe it's the same language. A new one-way road is built from M to N. Each car now has 3 possible routes to travel. On the road from M to N, 1 car takes 7 minutes. ठीक है. So everything is same as the previous one. Now question is, if all the cars follow the police order, what is the minimum travel time from A to B? So we just saw what is going to happen, right? The minimum travel time is going to be 29.9 minutes. That's what the time they are going to take in order to reach there. है कि नहीं? इससे कम तो नहीं हो सकता, राइट? ठीक है, तो आंसर इसका सी होना चाहिए. ठीक है, 29.9. ओके, नेक्स्ट सेट. यस सोनाली, बहुत ही रिसेंट क्वेश्चन है, बहुत रिसेंट इन एज इन एनीथिंग व्हिच इज इन द लास्ट 5 years इज कंसिडर्ड रिसेंट. Yeah, good afternoon, Ruchin. Difference needs to be negative for stability. Divij, what do you mean by that? Difference should be negative. ये क्या कहना चाह रहे थे? Difference, when they say the word difference, actually difference means first number minus second number. When we say absolute difference, it means smaller number should be subtracted from the larger number. Doesn't matter whether they are positive or negative. So stability के लिए this need to be as close as possible, है ना? Okay, so this is a question where I'll have to hide myself. Reason being, we need this graph, and I believe Devet, Sonali, we did this question yesterday, but we did not solve all the questions. So in an 8x8 chessboard, a queen placed anywhere can attack another piece if the piece is present in the same row or in the same column or in any diagonal position in any possible 4 directions. So let's take an example. Let's say queen is placed here. So queen travels either in the same row, or it travels in the same column, or it travels along the diagonal. So these are the 8 directions in which queen travels. Okay, what if queen is not here? What if queen is let's say somewhere here? Then queen travels in the same column, in the same row, and then it will travel along the diagonal. So as you can see that the number of squares that it can move to will become less, right, as compared to the previous example. Now, it is given that the columns are labeled from A to H, that is from left to right, and the rows are numbered from 1 to 8 from bottom to top. The position of a piece is given by the combination of column and row labels. For example, C5, so you go to C, you go to 5 and see where they meet up. This is a combination, that means the piece is in Cth column and fifth row, right? Okay, this is how exactly a chessboard is. Okay, Question is, if the queen is at c5, so let's put queen at c5. So this is where queen is. And the other pieces are positioned at c2. So c2 will position it here. g1, so g1 is here. g3 is here. g5 is here. And a3. Then how many are under attack by the queen? So if we follow the queens, so this is 1, this is 2nd, this is 3rd, this is 4th, right? There is no piece above queen, to the left of queen, and the diagonal, as in northeast and northwest mein to koi piece hai bhi nahi. So looking at this, can we say there are going to be four such pieces that are under attack, right? So 4, C option. Okay. Next, the queen is at c5, right? So this is where queen is. And if the other pieces are at positions a1, so this is where one of the pieces is, a3, then we have b4, then we have d7, then we have h7, and then we have h8. Then which of the following positions of the queen results in the maximum number of pieces? Acha, the queen position is not c5, queen's position is, we have to check depending upon each option. So let's look at f8. So if you go to f8 and place queen here, so the queen will be able to attack one of them and then one more. So queen will be able to attack only 2 pieces, right? Let's check now a7. So if queen is at a7, this is where queen is. So queen will be able to attack 1 and then 2, only 2 of them again. If we place queen at c1, queen will be able to attack 1, 2, and that's it, right? So only 2 of them. So obviously we know the answer is going to be D, because we need to find out maximum number of pieces under attack. So अभी तक तो सारे 2 चल रहे हैं, तो इसमें से तो कोई option होगा नहीं, D option ही होना चाहिए. Let's verify this. If we put at D3, so this is where queen is. So queen will have 1, 2, 3. So 3 pieces it can attack, which is the maximum among the given options. So D is going to be the answer, right? Okay. Next one. If the other pieces are only at positions A1, so let's put at A1, then we have A3, then we have B4, then we have D7, then we have H7, and we have H8. Then from how many positions the queen cannot attack any of the pieces, right? So this is going to be little time consuming, and you have to be very, very observant. So what we are going to do is, we are going to look at column wise first of all. So can we say queen cannot be at any of these columns, because at least one piece will be there. Queen cannot be at any of these columns. Queen can be at some of the places, some of the squares in this column. इधर नहीं हो सकती, इधर, 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 इधर नहीं हो सकती. Now, from the columns now, let's look at the rows. Queen cannot be in this row, cannot be in this row, not in this row, not in this row, not in this row. So queen can be in one of these 3 rows. Now, patiently, let's, take one column, one row, and then start solving. So one column, one row, so queen can be here. Let's try to put queen here. So diagonally, if you check, this is the place where it will not work. Let's move to the next row now. So if I put queen here, queen will still be able to take out one piece at least. So queen cannot be there. Let's move to the next one. So suppose queen is here, queen will still be able to take out one piece, this one. So we can't place queen here. That tells us कि queen ये third वाले column में भी नहीं हो सकती. Next column and the first row. Suppose queen is here. So queen will take out one of the pieces. So we can't place queen here. Next is, what if we place queen here? If we place queen here, queen will take out diagonally 2 pieces. So queen cannot be here. Next place is here where we can put queen. And yes, queen can be here. Reason being, it will not be taking out any of the pieces that we see, neither horizontally nor vertically nor diagonally. There is no piece in it, in its way, right? So एक हो जाएगा आपका place E2. ठीक है? Next. So we are done with this one. Let's move to the next column. This column and this row. Can we place queen here? No, we can't, right? Two pieces are getting attacked by the queen. What if queen is here, still getting attacked? What if queen is here? Yes, queen can be here at F2 because neither in row or column or diagonally there is any piece. So we are done with this particular column as well. Let's move to the next one. Let's look at G6. So G6 pe, if we place queen here, one piece is under attack. Next, if we place queen here, no piece is under attack. So the next one we can have is G5, जिधर में queen किसी को नहीं attack कर पाएगी. Next, if we move queen to the last position, which is here, so again, G2 पे भी, if we place queen, what we will find is queen will not be attacking any of the pieces, right? So we are done with this particular column as well. So can we say there are 4 such places on the entire chessboard where we place queen, then none of the pieces are in its way? 4. Right? Very patiently had to check first of all which rows and columns queen can actually go, may actually go, and eliminate all those rows and columns where queen should definitely not go. And once we look at the cells that are associated with the respective row and column, at putting queen at that cell, we need to check diagonally as well. क्योंकि row and column में तो नहीं हो रहा, वो तो हमने पहले ही eliminate कर दिया case, isn't it? Devij, the answer to that question is wrong given. The answer is not 2. Because nowhere in the question, I think you're talking about the root wala. Nowhere in the question it is given that the cars, they are supposed to take MN route. ठीक है, वो एक errata है, as in there is an error there. Got it? Devij? 29.9 and 30 is what we got. So, okay, so I'll take you there. 29.9 and 30 we have got. इससे तो ज़्यादा ही है ना, 32, 33. How come this be the answer? And it is nowhere given that it is compulsory for at least one car to take that. Okay? Right? It's nowhere written. I hope this is clear. काफी लोगों को उस क्वेश्चन में सेट में दिक्कत आती है क्योंकि हर जगह उन्होंने वो 2 आंसर देखा हुआ है. Okay. This was the 7th one, right? ठीक है, C is the answer. Let's look at question number 8. Suppose the queen is the only piece on the board and it is at position D5. So D5 is where queen is. So let's say queen is here. In how many positions can another piece be placed on the board such that it is safe from attack from the queen? So obviously we cannot place any piece along this diagonal. We cannot place any piece along this diagonal. We cannot place any piece along this vertical, along this column, and any piece along here. So there are 2 ways to solve this. Either count how many places did we not strike out or how many places the line is not passing through. या फिर आपके पास total 64 हैं places. Subtract the places that we have, put the lines across, the squares where we have put the lines across. So एक position तो queen का position है. Okay. Now let's count diagonally. 1, 2, 3, 4, 5, 6, 7. So 7 more places it cannot go. So this is primary diagonal. PD लिख दिया मैंने. Next, let's look at the secondary diagonal. So 1, 2, 3, 4, 5, 6. So another 6 places we cannot put any piece. So secondary diagonal we have removed. Let's look at the column now. So 1, 2, 3, 4, 5, 6, 7. So another 7 is gone, right? This is vertically. Let's talk about horizontally, how many places we will have to get rid of. So horizontally, we are going to have 1, 2, 3, 4, 5, 6, 7. So another 7 of them, right? So this is going to be 64 minus 677 is 20. So minus 28, which is going to give us 36. So there are 36 places wherein we can place the other pieces, any of the other pieces, and it's not going to be attacked by the queen, right? Answer is going to be C, 36. हाँ देवेश, तो वो see, don't trust everything that is online, right? People assumed, maybe wherever you have seen, people may have assumed that there is at least one car, one vehicle that is supposed to take the MN route, but it is nowhere written. ठीक है, तो हो जाता है क्योंकि एक ने आंसर करा, दूसरे ने उसका कॉपी करा, तीसरे ने दूसरे वाले का कॉपी करा, एंड इफ दिस कंटिन्यूज, यही होता है. Misinformation spreads like this, right? Okay, so that's all. I hope everybody liked this session, understood the 2 sets we did today. They were pretty easy, especially the second one. And yes, you do get such kind of sets in CAT. So do not expect a lot of sets in a particular slot. Worst case, not worst case, बेस्ट केस में 2 ऐसे आपके सेट्स हो सकते हैं. वर्स्ट केस में एक तो होगा ही होगा. So there is 1 or max 2 sets that you can expect that you can solve in another 10, 15, 20 minutes max, right? So meet our CAT 2022 toppers. If you want to be one like them, you can join our CAT comprehensive program online batch, wherein these are the takeaways, starting from the tablet to more than 75 mocks, helping you out with your GDPI and VAT preparation, booklets, and more than 10,000 questions, and of course along with that the concept and the problem solving sessions. Okay, for this you can write a scholarship test. The scholarship test is supposed to happen on 28th May at 11 a.m. Make sure that you register for this. The registration link is given in the description and in the chat, so you can get up to 90% scholarship here. Okay, on 21st of May at 11 a.m. Mr. Gautam is going to talk about 6 months to CAT 2023. You may have watched the video at the beginning of this session as well, right? So he's going to discuss about the test taking strategy and how you should be preparing for the next 6 months. Make sure that you register and do join the session. You can also download our app and attempt our daily section wise quiz. Okay, it's all for free. All you have to do is download the app and log in. And just like today's session, we will continue with our 500 most expected CAT questions every day. Make sure that you subscribe the channel so that you do not miss out on any of the sessions that we're going to take. Everybody, please make sure that you like, and if you haven't subscribed, please subscribe, and please share the videos with your friends who are also preparing. And this is not just for MBA, this is also helpful for other exams, right? Don't forget to follow us on Instagram and like our Facebook page, and you can join our Telegram channel as well. Thank you everyone for joining. I'll see you again very soon. Until then, take care. Bye-bye.